Hi there and welcome back to the Good Tutor SAT Premier Prep course, and today we're going to continue our look at the Heart of Algebra subsection of the SAT Math sections, and specifically we'll be taking a look at word problems relating to linear inequalities. So it'll take those inequalities that we just learned about in the last video and give a quick lesson and an example problem of how to form one of those inequalities from a word problem. Alright, so first and foremost, word problems relating to linear inequalities apply to more real-life situations than just giving you an equation or two, of course, right? Now, the key to take from here is that they may or may not be in that y equals mx plus b form in slope-intercept form, right, is what we call it. Like the one we're going to look at, we'll be building an equation that is actually not in a slope-intercept form. And in the case of inequalities, that's y and then a space for whatever inequality sign will go there, mx plus b. Very similar to that of equations. Okay, so now we'll be taking a look at a word problem here. So if we read it, it says, to achieve the sales goal for the month, a donut shop has to sell a minimum of $8,800 or $8,800 of donuts and coffee. A donut sells for $2 and a cup of coffee sells for $4.25. If D represents the number of donuts and C represents the number of cups of coffee, where D and C are positive integers, what inequality would best describe the situation? All right, so first I would take a look at this and ask ourselves, what is our sort of total value, or what is our big value that our inequality is going to have probably isolated, right? In that case, if you want to think about it for a second, it should be 8,800. Okay, so that's the minimum, right, that this coffee shop has to make by selling the donuts and coffee. Then we have to know what each one sells for, and we said donuts were $2 and each cup of coffee was $4.25. So now, if we start with that total value or that minimum value, we have 8,800 or 8,800 something, right? One of our values will go there. One of our inequality values, or inequality symbols, is, so 8,800 is, okay, blank, 2, and then it's 2 for each donut sold, right? So 2D, meaning $2 times each donut that's sold, plus 4 and 25/100ths, or 4.25, times C, or each cup of coffee. All right, this looks good, and now we just have to pick an inequality symbol. Less than or equal to, greater than or greater than or equal to. So now let's see. Our problem says that they have to sell a minimum, which means what we sell in the 2D plus 4.25C has to be at least, meaning greater than or equal to 8,800. And since 8,800 is listed first, it would be, so if this side, that right side, must be greater than or equal to, it means that left side is less than or equal to. So 8,800 is less than or equal to 2D plus 4.25C would be our answer. Or if we did it flipped or inverted, it would be 2D plus 4.25C is greater than or equal to 8,800. Okay? And now we'll just take a look at some symbols here that you'll see in word problems, and we saw one of those, we used one of them there, of course, and then the words that go with them, that will accompany with them, so that you know what you're looking at and what to put into your inequality should you have to build an inequality or solve for one. All right, so the words greater, more, or longer have to do with the greater than symbol. Less, fewer, or shorter would be the less than symbol. The greater than or equal to symbol would be no less than, at minimum, no fewer than, or at least, sort of like the minimum that we saw in that last one. And then no more than, at maximum, no greater than, or at most would correspond with the less than or equal to sign. All right, and that's it for this video. In our next video, which will be the last of the Heart of Algebra subsection, we'll have to deal with systems of linear equations.